Our first speaker of the day is Sandeep Virmani from Hunnarshala. I have known Sandeep in various looks also. I very briefly saw him after the Gujarat earthquake. We were doing some stuff and he was literally coordinating the efforts in touch with a lot of agencies pouring in to give assistance. I have also spent fun time with him in Japan, talking about various things besides architecture and buildings, about pastorals, about seeds that can stay dormant in the ground for 12 years if it doesn't rain and still the grasses can spring back. And what I have learned from my engagements with him is that being here, being architects, is not about buildings. It's about people. Buildings just happen to be spaces where people have to spend some time, and these buildings, of course, need to be safe. But it's about people, their lives, and how you create an environment that they comfortably can be part of. Sandeep, take over.
Need to continue talking. It's great to be among students. I'm not going to be partial to this side. Everybody will be facing this side and obviously. So, in Anshu's style, he just called me up and said that we're going to be talking to students. Why don't you join us? So I had no idea that I have to make a presentation. There's going to be such a beautiful screen to show my work. But I haven't got any slides. So I'm going to have a conversation, as I had promised. And what I'm going to...
You do have 4 slides. They are on the screen for you.
Okay.
And also, you will tell the head so that in the recording we don't get your head in the front of what
I'll keep walking up and down. But thank you, students, for having me here. Thank you, SPA, for having me here. Have a nice meeting you here. And all these people that I keep meeting in disasters, the first time I'm meeting them not in a disaster situation. So it's great to meet all of you here. So what I'm going to share with you is the excitement of our hinterland and the knowledge of our hinterland. That's something that bit me a long time ago, and I have never come back to the city ever since. And so I'd like to share some of that excitement, and I hope I can transfer some of this excitement to you so that you guys can go just to beyond your city, go into the rural areas and start getting excited about all the fantastic knowledge that people have in our rural areas. As it's really nice to be hearing that communities are to be the focus in terms of them actually building, because I remember when we began, the experience of Latur and Uttarkashi was behind us, where 2 big earthquakes had happened, and that had been disastrous in terms of administrations and engineers trying to get contractors to build for me. And I think a big shift started happening sometime then that this really doesn't work. And the Gujarat earthquake was a very big shift. It was a quantum leap in thinking and change in not just setting up small examples, but actually at policy level. And actually being able to have multilateral agencies like the World Bank, who now are the main proponent of the owner-driven process of construction all over the world. So, and the reason for that is very simple. Just as all of us know how to make a cup of chai, how many people know how to make a cup of chai? Oh, hell of a lot. Okay, how many know how to make your breakfast? Eggs and toast. How many people know how to make a full meal? How many men know how to make a full meal? Not so many still. Okay. So just as you know how to make a full meal, or you know how to cook, how many people know over here how to make your own house? You're architects, for God's sake. But in the rural areas, what you find is that just as people know how to make their cup of chai, they also know how to make their house, or at least know how to make different parts of their house. And therefore, it's only natural that we go to them and ask them that how do you build your house and how do you make it better. So I remember in the post the earthquake in Gujarat in 2001. I was there, I live in Bhuj, so I ran out of my house as my first story collapsed. But when we realized that the city of Bhuj, it's a small city, we're just about 150,000 people, and 7,000 people died in my city. It's almost 4.5% of my city. It's very big for an earthquake. And just we are joining our area where the epicenter was, which was the Bangi region, where about 7,000 people live. Not a single structure broke. Not a single building broke. Forget about anybody getting injured. And so it created huge worldwide attention on what was it that that this area did that Bhuj was not able to do with all its engineers and all its norms of construction. 2 to 3 days actually. And we asked them that, look, we guys didn't mess up the rural areas, we messed up our urban areas. So what is it that you guys did in the Bandi? That why is it that you have not been able, that none of these structures broke? But before I go into that, I think it's important for us to understand how does a building break? I don't know if Anshu and Paru have had any classes on earthquakes and how they affect buildings and what is it that needs to be designed. Anybody here would like to explain how a building actually crumbles in an earthquake? Anybody wants to try? Come on, architects. You don't.
You've been engaging with all of this in the last few weeks.
Yes.
One of the things that we learned was that during an earthquake, the walls that are joining at the ends, they fall apart. So then the roof collapses and the entire structure crumbles.
Absolutely, absolutely. And that is very important to understand that in an earthquake, it's not the foundation, it's not the roof, it's the walls that need to be designed. Because as the vibrations of the earthquake transfer from the foundations into the walls, there are two forces that happen. One is the vertical forces, which create compression. Our buildings are very well designed for compression. You can keep loading them and you can make multi-stories, and it'll still stand with the same compressor strengths. But it's the lateral thrusts that when the earthquake starts putting the waves into your walls, that the square structure begins, the walls start becoming like paper thin. And the corners, where this is working like a buttress, this is working is like a paper thin thing, is the corner where from the top, the crack starts and start traveling down. And by the time the crack, if it at all, before the earthquake stops, reaches the ground, that's when the wall collapses. And if the wall collapses, the roof falls on your head. Now the way in which engineers have learned how to solve this problem in housing is, anybody here wants to take on load-bearing houses, how does a building not collapse in modern in Delhi? Of course, we don't know if probably all of them will collapse, but how do engineers design a box so that it doesn't collapse anymore? Any takers? She's impressed us with knowing how they break. Anybody wants to impress us with how they don't break? Yes, try.
If we have members which will, like on the corners, a vertical member of probably RCC, if we insert it, then it will help to stop the crack from reaching the ground.
Okay, so what you're saying is that if you have a beam or a band with steel in it
Or some
that
other
travels
member,
horizontally around, then the crack will be stopped.
yes, it will reach the ground.
That's true. So at the lintel levels, you put a continuous band so that when the crack starts from the top, at the lintel it will get stopped. That's one way to do it. Any other ways? Yes?
So by providing brackets
So that the corners can be strengthened. Good.
and there is another technique. When the earthquake came, the whole building shakes.
Yes.
So if this is shaking like like this, it will break down. But if the earthquake came, we are able to shake this in
Together.
The whole
That's a
building
little
acts as
tough one. That's not so easy.
And
Yes.
another way is by using some dampers like tune mass dampers, which are used by the Akashic Aiko dam, that is in Japan or in other skyscrapers buildings.
So how do you do that?
By providing tune mass damper, which is mainly for the earthquakes.
Okay, okay. I'm talking about single-story load-bearing structures. Let's not get into complicated structures. Okay, one thing that they do is steel has got tensile properties. So it can spring. So if you have a column with steel in it, if the lateral thrust pushes it down, it will tend to bring the building back up again. So in the corners, they tend to put some steel into it so that as the building sways, the steel is able to pull back the building up again. Now this is a typical system that has been applied for single-story structures by engineers all over the country and several other countries. So you make horizontal bands, vertical some steel, and you cage the entire box in such a way that it can keep moving and not collapse. But when we go to our rural areas, you realize that there are at least 30 different ways in which every region has developed their own method of dealing with the disasters of their own areas. So in the earthquake in Kutch, when we were speaking to these masons, the Meghwal community who builds these structures, they told us that they make circular structures, so that if there aren't any corners to break, they won't break. And the way they do it is that when there are lateral thrusts for a circular structure, it works like an arch. So an arch is something that is very strong. If you keep putting more pressure on it, it actually becomes stronger. So you understand? So a circular structure like these, they are called bungas over there. When they move laterally, the forces of the earthquake are pushed back in circles into the structure, and there are no corners to collapse. And this is something that a Meghwal mason told us. And then, of course, there were many structural engineers who validated this. There was a technical guideline that was prepared, and people were allowed to make these bungas again. So the entire Bani region, about 1,200 bungas like these came up. So, and when we were talking to these masons, they told us, so we said that when was it that you guys started building like this? Because tradition doesn't mean that for the last 2,000 years or 4,000 years you've been building exactly the same way. In parampara, everything keeps changing. Parampara itself means constantly changing. And what these people did was that they told me that in the 1819 earthquake, which was a massive earthquake of the same nature, is when this community and the Meghwal sat down together and decided to start making no more square structures. Square structures were made, but they were very small structures, only for storing of grain and things like that. Or for living, they converted to bungas. So it's a new tradition, only 200 years old. But there was science applied based on a certain understanding of the way earthquakes happen. And earthquakes happen along zone 5 is the entire Indian plate as it has come up and hit against the Eurasian plate. So from Kutch through the Himalayas, all the way to Mizoram, all the way to Nagaland, is the entire area where you have these earthquakes. And every region, every community has come up with a different way of dealing with earthquakes. Similarly, in Uttarakhand, do we have another slide on that? They have a different way of dealing with earthquakes. What they do in Uttarakhand is that the mud and stone walls are braced or have a containment reinforcement. So they put wood on both sides and tie them together in between. So what I don't have a, it's a beautiful technique which holds the entire wall together between wood strips, and then they're connected in between like that, so that you can use mud as a mortar and stone, and yet be able to make completely safe walls. So now that we can't use wood, traditionally wood was easily available, So what Rajendra and Professor Jagdish worked on is, can we use galvanized wires instead of wood and do the same thing? So these walls, unfortunately, you can't see it over here, but these are several wires that are holding the entire wall together. And this is a traditional technique of Uttarakhand. Hundreds of temples, houses over there, even 4-story structures have never had any problems with earthquakes because they have been able to use this age-old tradition of dealing with them. I'll take you to another very important method of dealing with earth. Is this the only one we have? Is there another one? This was not the traditional one as well, this was just a sample. But there's a saying over there, in Mithilanchal where Sita came from. It's the floodplains and of the Ganges. And they say that whenever the Ganges is angry and in fury, Ma Ganga starts flowing, and anything that comes in its way, it picks it up and takes it away all the way to Calcutta and beyond into the sea. There's only one creature that bends and touches my feet, and therefore cools down my anger, says Ma Ganga. And therefore I spare it, and that is the bamboo. It has the tensile properties of steel. And therefore, any building that is made in bamboo can very easily take all kinds of lateral thrusts. And so the entire Northeast, which used to build like that, unfortunately they are building horribly now. And so in Bihar, when we work with what were called the Dabia Mistris over there, they are not carpenters, they are bamboo workers. There's a distinction between them. And they build the entire structure with one little knife. Well, it's not a little knife, it's very large. It can do more than just cut bamboo. But the entire structure is actually made with one knife. And that's what's so fascinating, that the minimalism and the simplicity with which you can do so much. And that is what you learn in design. Or at least we're supposed to learn in design. And how can we be simple and yet do more? It's very easy to do a lot and then yet achieve a lot. But invariably, whenever you do more, you're also creating problems, which then you try and solve in a different way. So here's a very nice way, and this is something that traditional knowledge systems have followed all over the world. Never fight nature. Go along with nature. Modern science has tended to understand nature, and there's a certain amount of egoism that came in with it. That we can deal with nature. That we can actually force our way and be a competitor to nature. And so we can change things. And as a result, you will try and make rigidity. You bring rigidity in your structures. That I can be so strong that nothing can affect you. Whereas that's not the way traditional wisdom thought. They always swayed along with nature. And this is a very nice example. Similarly in Kashmir, when you were talking about in 2 months how you build 20,000 structures. In Tangdhar Valley, when we were invited to work as ODRC over there, that was also the birth of ODRC, where we sat down and we worked, because the engineers were insisting that you have to anchor the building strongly into the ground. Otherwise, the aftershocks will again break them down. And the people were just not moving. They were saying that, no, this is the wrong method to build. So we went over there and we said that, okay, show us structures that have not broken. Both structures that have fallen down were not going to tell you very much of how to build back better. But buildings that withstood the earthquakes or any disaster tell you a lot more about how they were able to withstand that problem. And they have what is called isolated foundations in the Kashmir Valley. Today, isolated foundations has become very famous. Do we have a slide for that? Okay, anyway. So the isolated foundations works like this, that the entire building is not anchored into the ground. You make up to the plinth, and then you put a wooden band on all sides, and then you put the superstructure completely separated from the understructure. There's nothing connecting the plinth and below to the superstructure. And for engineers, this was a scary proposition. You're actually not going to anchor the building into the ground. It is going to just fall even if you just push it. But what does it do? The base isolation system is basically ensuring that the vibrations of the earth are not transferred into the superstructure. Or very few vibrations are transferred into the superstructure. This is a technique that New Zealand understood very well. And they have developed a system, a very similar system, using rubber bushings, very high density rubber bushings between the column, which can be placed between steel, high rubber bushings, so that when there's an earthquake, the foundation will move and the entire superstructure will remain intact. And that's the technology that we imported from New Zealand at very high cost to make a hospital in Bhuj, when our own people from Kashmir had already done this many, many centuries ago. I'm just giving you a few examples to tell you how there is a plethora of knowledge and understanding in our rural areas. There are about 30 such technologies just to deal with earthquakes. I'm not talking about floods and wind and things like that. And I'm just sharing 3 or 4 of them with you. And this is something that bit us. This is what made us so excited, that such simple ways of building, having a deep understanding of the way nature works. But there are 2 things. One is, how can you understand nature to make your buildings resilient? But the other, more important thing is that how do you make yourself resilient? That's another thing that we have learned from our rural areas. Sitting in air-conditioned environments like this only makes us more vulnerable. It's of course letting out greenhouse gases outside, which is making others' lungs vulnerable. But we don't know how to take the differences in temperature any longer. We don't know how to take variation in rain any longer. Our cities flood the moment there is a precipitation that was not decided, which is a little more than what was happening in the last few years. And that is why you find that in the last 10 years or so, every year there are at least 6 or 7 cities that get flooded in the monsoons. With climate change events, intensity of rain is increasing, the coefficient of variation of rain is no longer in our control. And so I'm now going a little beyond understandings from just architecture, but how do you make yourself resilient? How do you look at so the pastoral communities of this country, pastoral are in the nomadic communities who breed animals and who supply these animals to our agrarian economy so that we can get our glass of milk early in the morning. And these pastoral communities are extremely good scientists in understanding how to create breeds of animals. What happens so before I come to that, let me tell you a little bit about how climate change is creating these coefficients of variations. So, for example, the Gangetic Belt. For hundreds of years, rain has followed a certain pattern. There's about 1,000 millimeters of rain that happens along this entire area. And it happens consistently in the month of July, September, and then October. So you get 3 showers, 1,000 millimeters of rain, and for hundreds of years this has been happening. And now with climate change, what is happening is that this assurance that you will get 1,000 millimeters in these 3 showers is changing. So over the generations, the seeds that have developed naturally in these areas have known how to deal with this pattern of rain and the humidity and the temperatures that go along with it. Now when there's a change, the same seeds don't perform. The productivity starts decreasing drastically. The disease vectors increase. And this is why the productivity of grain starts going down. Which means the chances that this pattern will change is only 5%. But in arid areas of the world, the coefficient of variation of rain is 60 to 70%, which means the chance that the same pattern of climate will happen again the next year, there are only 40% chances that it will happen the same way. There are 60% chances that there will be another pattern. And so farmers, especially based on rainfall agriculture and not on canal-based irrigation, had developed a method of understanding what is the pattern in this 40%. There has to be a pattern. So for example, the deserts of Rajasthan and Kutch, the rainfall has this variation. And they had realized that every 5 years, over there the general average rainfall is about 250 to 300 millimeters in a year. But they did not rely upon that. What they decided was that in every 5 years we are short of 1,000 millimeters. Any 5 years there might be 50 millimeters in 1 year, there might be 400 millimeters in another year, there might be 300 millimeters in another year, but in every 5 years we know that we will get 1,000 millimeters. You take any 5 years and you can actually look at the, we did this because when we asked them, they told us this, we looked at the last 150 years rainfall records and you could take any 5 years and you were assured of at least 1,000 millimeters. So they built their entire grain and fodder security based on 5 year cycles, not on a single year cycle. Are you understanding what I'm saying? So you knew that in 5 years, if I plant my millets, only 3 years I'm going to get grain. 2 years I have to have at least fodder. So that is why they had a more emphasis on animal husbandry and agriculture going together. Because fodder was a much more, the chances of getting fodder at least from your plants was much greater than getting grain as well. And not only that, we have done a detailed documentation of the millet seeds, the bajra seeds in Kutch region. And what we found was that they have 17 different types of seeds of bajra. 17 different types. And each seed can be, they can give you the character that this particular seed is a late growing seed. Which means if the rains fail you in June or July, then you can still grow this in September. It's a short growing cycle, so within 60 days you will get grain. But if the rains happen in June or July, then you can go up to 120 day cycle and you have 3 different other varieties of bajra. There are certain varieties where the tillering is more and therefore you get much more grain. In some, the stock will grow larger and therefore you get fodder but less grain. There are still others which are so specialized that they have a higher iron content in their seeds, so which is good for pregnant mothers, and they grow that specially only for pregnant mothers of the village. So they had 17 different types of seeds to be able to deal with the coefficient of variation of that region. Unfortunately, the hybrid seeds that we brought in were only obsessed with only production, and therefore they became vulnerable when the climate change started happening. And so now we are getting desperate and we are actually trying to take genes from spiders and put it into tomatoes and what we call GM crops today, which are making us even more vulnerable. I'm taking you a little away from architecture per se, because when you go to the villages and you talk to people, when somebody used to ask me, who am I said, I'm an architect. They said, no, we are asking you your name. So in the villages, if you go, there's nobody who is only one thing. They're first human beings. And we must all remember that. And so if you start talking to them about architecture, they will talk to you about architecture, they'll talk to you about medicine, they'll talk to you a little bit about cooking, they'll talk to you about child rearing. Unfortunately, our specialized communities want to slot us as one peg in the wheel. You're an architect, you just focus on doing that while we go ahead and do all the shit that we want to do. And you need to understand this because you belong to an industry. The building industry is one of the most polluting and the most exploitative industries of the world. I don't know if this has been taught to you in school. The greenhouse emissions that the building industry lets out is 25 to 30% of the total greenhouse gases of the world. And are you addressing that? Are you being taught how to address that? In India, we pay only 3%, 3.6% people pay the minimum wages to our labor on site. The minimum wages are set by the government. Only 3.6% of our industry pays them even the minimum wage. It's a highly exploitative industry. Forget about all the benefits that we should be giving them. So my only request to all of you is that when you look upon or when you go and have your pani puri, that bhaiya who's come from UP, you'll be surprised how much he can offer to you. The woman who comes and cleans your house and cooks for you, if she's from Jharkhand, talk to her about what she knows about Jharkhand. And she'll give you a huge amounts of knowledge. When you see a whole herd of cattle passing through the streets of Delhi, don't swear at them because that guy is creating breeds of animals which is responsible for the white revolution of this country. And if you have time when you go on a holiday, don't just enjoy the nature, go and sit down and have a cup of tea with those guys over there in the farms and talk to them about farming and building homes. Thank you very much.